Good morning, everyone. Today we are going to study about the engineering graphics, class 22. So last ക്ലാസ്സിൽ നമ്മൾ കുറച്ച് കാര്യങ്ങൾ പറഞ്ഞിട്ടുണ്ടായിരുന്നു. ഈ ക്ലാസ്സിൽ നമ്മൾ പറയാൻ പോകുന്ന ടോപ്പിക്സ് എന്ന് പറയുന്നത് ഐസോമെട്രിക് ഡ്രോയിങ്സിനെ കുറിച്ച്, ഐസോമെട്രിക് ഡ്രോയിങ്സ് ആൻഡ് ഐസോമെട്രിക് വ്യൂസിനെ കുറിച്ചാണ് നമ്മൾ ഈ ക്ലാസ്സിൽ പറയാൻ പോകുന്നത്. ഐസോമെട്രിക് വ്യൂ ആൻഡ് ഓൾസോ ദി ഐസോമെട്രിക് പ്രൊജക്ഷൻ. ഓക്കെ, നൗ what is exactly the isometric drawings actually? So it's a type of pictorial projection which all the three dimensions of an object are shown one view, and if required their actual size can be measured and directly from it. അതായത് നമുക്കൊരു ഡ്രോയിങ് തന്നു കഴിഞ്ഞിട്ടുണ്ടെങ്കിൽ നമുക്കൊരു ഒബ്ജക്റ്റ് തരികയാണ്. ഈ ഒബ്ജക്റ്റിൻ്റെ 3-dimensional വ്യൂ ആണ് നമ്മളിവിടെ കാണുന്നത് ആക്ച്വലി. സോ വി ഹാവ് ടു സീ ദ 3 dimension ഓഫ് ദാറ്റ് ഒബ്ജക്റ്റ്. ഓക്കെ, ആ ഒരു 3-dimensional വ്യൂ ആണ് നമ്മളിവിടെ നമ്മുടെ ഡ്രോയിങ്ങിൽ വരയ്ക്കാൻ പോകുന്നത് ആക്ച്വലി. ഒരു ഒബ്ജക്റ്റിനെ നമ്മൾ കാണുമ്പോൾ അതിൻ്റെ 3-dimensional വേ അല്ലെങ്കിൽ 3-dimensional വേയിലാണ് നമ്മൾ അതിനെ കാണുന്നത് ആക്ച്വലി. ആ ഒരു 3-dimensional വ്യൂ ആണ് നമ്മൾ ഇതിലേക്ക് വരയ്ക്കാൻ പോകുന്നത്. ദാറ്റ് ഈസ് ആക്ച്വലി ദി ഐസോമെട്രിക് ഡ്രോയിങ്. അതിന് ചില കണ്ടീഷൻസ് ഉണ്ട്. അതിലെ ടിപ്പിക്കൽ കണ്ടീഷൻ എന്ന് പറയുന്നത് ദിസ് ഈസ് എ 3D ഡ്രോയിങ് ഓഫ് എൻ ഒബ്ജക്റ്റ്. So the 3-dimensional axes are maintained at equal inclinations with each other. അതായത് നമുക്ക് ഇതൊരു 3-dimensional ഡ്രോയിങ് ആയതുകൊണ്ട് ഒരു 3-dimensional ആക്സിസ് ഉണ്ടായിരിക്കണം. ആ ആക്സിസ് at equal inclinations. Okay, the 3 axes which are having an equal inclination. Example, each other having a inclination of 120 degree. And now what's about this? More about this. So the isometric drawing can be drawn in a numerous way. Okay, like all these drawings may be called the 3-dimensional drawings or the photographic or the pictorial drawings. Here no specific relation between the H, L and D axis is maintained. So you can see is a picture which having a 3 axis D, L and H. Okay, so these 3 axes having an equal inclinations with each other actually. Okay, you can see the pictures of these 3 types actually. Now here you can see, now the observe below that the drawings one can note the specific inclination among H, L, D and axis. So that is iso means it is same actually, that is similar or equal. So you can see that there is an equal inclination among H, L and D axis. So each is 120 degree inclined with each other too. Hence it is called isometric drawing. Now the purpose of the isometric drawing is to understand overall shape and size and the appearance of an object prior to its production. Now we can divide the isometric drawings into 2 types. One is isometric view, another one is isometric projection. The isometric view, it is actually the true dimension or enlarged up to 122.5%. Or isometric projection is which is actually drawn by using an isometric scale. So what is isometric scale? That we will tell you about this in the next step. Okay, so what is exactly this isometric scale, and or maybe we can use the reduced dimensions also. So in the left side you can see that there is an isometric view, and the right side you can see that there is a isometric projection. So you can see that here one is in a true shape or maybe in the true dimension or maybe in the enlarged one in the isometric view. See here in the middle you can see there is an isometric scale is drawn actually. How this isometric scale is drawn? So there is a 3 points mainly, there is 4 points A, B, C, D. Okay, so first from the point A we have to draw a line to AB line. You have to draw a line AB and then draw a 30 degree angle and 45 degree inclined AC and AD. Okay, and then respectively on AD. Now mark the divisions of the true length. So you can see that AD is actually the true length. In the true length you have to mark it 0, 1, 2, 3, 4 like etc. And then you just draw a vertical lines to the AC. And you can see that there is another point 0, 1, 2, 3, 4 in the AC line. And this is the isometric length for the each. When you are going to draw an isometric scale, you can see the dimensions for isometric length. You can take this AC length. Okay. So the divisions obtained on the AC gives the length for an isometric scale. Now there is an example we will study about this first problem. Okay, a square pyramid of 30 mm base, sides and 50 mm long axis is centrally placed on a top of a cube of 50 mm long edges and draw its isometric view of the pair. Okay, so there is a two solid shapes are there actually. One is a cube and one is a square pyramid. So when you place this cube over a floor and over that you have to place a square pyramid. So yeah, here the drawings are coming. First you have to draw an axis line and then take an angle between 30 draw two lines actually. Yeah, two lines which is these lines are in between 120 degree axis, okay, in the centrally 120 degree apart, and now you draw a vertical lines, yeah, you measure that 50 mm long from the center point to that edge, and then again vertical lines in the center point, and then again 50 you take it and then draw a vertical line. So in the 50 it is actually given the actual length, but you have to make an isometric scale actually. Okay, so first you have to draw an isometric scale and corresponding length for the 50 you have to draw from these 2 points. Okay, so in between these 2 points you have to draw a corresponding length of the 50 mm. Okay, isometric length. Now draw like this and then completed the square. Now you have to find out the center point. For that you have to draw an axis, two axes in the square, and you find the center point. And to make the dimension, like here it is given that is 30 mm base side. So now the cube is already done, but now we have to draw about the pyramid, square pyramid. So in the square pyramid, the base is given as a 30 mm. So this dark line is shown in the 30 mm. Okay, inside there is a 30 mm equally. So that is 50 mm one side and 15 mm other side. So it is 30 mm, 30 mm. Now that square is closed. Okay, now you have to take the height actually. The height is 50 mm long axis. So 50 mm long axis, it means that you have to take the corresponding isometric scale. Don't forget, you have to draw first the isometric scale, then isometric length you have to take it here actually. Okay, corresponding isometric length of the 50 mm. Okay, right. Now you just height you just mark as a 50. Here see, if you take the 50 mm isometric, don't use that length to show here dimension marking. Okay, you have to show the 50 mm. So it means that you have to show the actual length in here actually. Okay, don't use isometric length. For 50 mm, the corresponding isometric scale may be 35 or 40 mm is coming. Suppose you imagine 35 or 40 mm it is coming, but don't use that 35 or 40 in here actually. Use the actual length what it is given in the question. Okay, right. Now draw from the top to, because this is a pyramid actually, so draw the four sides. Okay, now draw the darken the lines which is you can see from here actually. So visible lines you dark, yeah, and draw these dimensions 50 50 and this is 31. Okay, so this is actually the complete drawing of the isometric drawing of that square pyramid and also this cube actually. So remember, this is a first problem. You clearly should understand about this problem, otherwise you can't move next one. Okay, so I think you understand clearly. First you have to take two bottom lines. Okay, first you have to draw an xy line, then place a point, and then 30 mm from this side and 30 mm from this side. Yeah, like you have to take 30 mm here and 30 you here, or 120 here actually, 120 degree, and then draw the corresponding lines actually. Okay, right. Now next problem, we move to next problem. A triangular pyramid of 30 mm base, side and 50 mm long axis is centrally placed on the top of a cube of 50 mm long edges. Draw isometric view of the pair. So what it is here actually? A triangular pyramid. So a triangular pyramid, the base is 30 actually. So that base is actually a triangular shape. Okay, for a triangular pyramid, base is also a triangle shape, and also this having a 3 sides also. Okay, right. Now there is a, it said that 30 mm is one of the base side actually, and 50 mm is height of that triangular pyramid. And now the second body is a cube actually. That cube is 50 mm long edges actually. Okay, so cube means it is all the dimensions is 30 mm actually. Okay, now the cube is placed in there on a floor, and over that there is a triangular pyramid is there actually. Okay, now we are going to that. Yeah, solution is given actually. So first you have to draw a line and mark a point, and then two lines as I told you. Then yeah, the central line you have to make. That height what it is actually, that is in the 50 mm cube. So 50 mm is the height actually. Mark 50 and 50. So all these dimensions is given, you have to change into corresponding isometric scale. Okay, isometric scale you have to corresponding change. That isometric length you have to choose here actually. Okay, right. Now the height, and here also height, and here clear, and then yes, and another line. So the cube is ready actually. So why I take each line, because you have to feel that whether this is how you are going to draw. So that is why each step I just drawn. Okay, just drawn to you, because you have to understand each and every step. So that is why. So don't skip the video actually. Okay, you have to focus each and everything what I am going to said in this video, and also you should clearly understand. Okay, now yeah, you have to draw a side. In the side you have to draw in a triangular, okay, triangle way, because this is a base actually. This is the top view. In the right side I draw here, it is your front top view actually, sorry, the top view. Okay, so you can see that it's just like this actually. Okay, yeah, so I'm going to show some points in here. A B C is outside, and in the central I pointed as a O and P. Okay, now I just draw a horizontal line, and here on another horizontal line for finding the center point. So I place a center point here and name it as a O, and I mark the point C here. Yeah, P, and there is A and B I going to draw, and then yeah, the another point C I mark it here, and I drawn in here actually. See, now so each length is corresponding length. How I go to AB length is actually how much it is in a the pyramid base is actually 30 mm, so it is 30. AB is 30. So first you have to mark a point P. Okay, mark a point P, because you find here actually A B C, you just draw in the top view, you can find the O point in the center. So from the O point how much distance is P, you just find the P distance, and then from the point P you just 15 is for A, and 15 mm is for B actually. Okay, so you can draw it's A and B. If you got it A and B, you just take 30 mm in your protractor or something like in your or you can take it as an angle, or you can take it to your angular dimension in the C actually, you can make it. Okay, right. So or 60 degree 60 degree you can mark it, and because it is a triangle, so each one is 60 degree, so you can mark it as the point C easily. Okay, or you can find O to C distance, and you can mark it here also. Okay, so anyway, you first you understand all the dimensions, you have to take it from the isometric scale. Okay, now yeah, height actually, so it is 50 mm height, you mark it. Now yeah, draw each lines in here corresponding points, and darken the lines, visible lines, and here it is your triangular pyramid. Okay, and then the dimensions you have to mark it later. Okay, I just forgot to mark the dimensions. Okay, you have to draw the dimensions also. So this is about the second problem. And coming to the third problem, here you can see that there is a cylinder, a square plate. Okay, so there is a long cylinder which is there actually, and also in between the cylinders there will be a square plate is there, and you have to draw in an isometric draw of this problem. Okay, so it's a front view and top view of this figure is given here. Okay, so a square plate is placed, sorry, the spelling is pierced, it is placed actually. A square plate is placed through centrally cylinder which comes out the equally from both faces of the pit, and it is front view and top view is shown, and draw its isometric view. Okay, so that spelling is mistaken. Okay, sorry. And now you are going to draw is, first you have to draw, this is front view and the top view is given, and now you, as I told you, you have to draw a line, and then yeah, two lines are equally inclined. Okay, and then you just draw the height, that is this height is actually 10 mm. Okay, the height of this box is 10 mm, and the length, you know that the length is 50 mm is given because it is a 50 mm yeah, lengthwise and widthwise it is 50 mm, so you have to draw, and the height is given is 10 mm, so 10 mm. So all the dimensions you should take in from the isometric scale. Okay, don't forget that actually. Okay, now draw these lines. Okay, and completed this cube, actually not cube, actually this rectangular plate. Okay, a square plate. Yeah, now mark the center. Okay, so yeah, you just mark the center, and you just inside, okay, inside you have to draw a square. Why this square is important actually? Because inside this square we have to draw the circle actually. Okay, circle. So you have to draw the circle. Okay, so the circle is actually the 30 mm diameter actually. So you have to draw the 15 mm right side and 50 mm left side. You just mark 15 and upper and lower, like that you make a square actually. So the distance from the center is 15 mm and 15 mm that, and here you will get a circle actually. Okay, but in the case of isometric, the circle is shown is circle is given as a, you can see it is as like a elliptical shape actually. Okay, when you draw a circle in the pictorial view, and you will get a yeah, here in the isometric view it is just like a elliptical shape. Okay, right. So for getting that, you have to draw any circle. If you want to draw any circle in an isometric view, you first have to draw what? A square plate. Okay, right. Now the cylinder height, you have to mark it the cylinder height actually. So this is an upper part height actually. Upper part height is given as a 30 mm. So draw the 30 mm height from the center and the both end sides. Okay, now you have to draw another axis. Okay, in the top, from the top point you have to draw another axis. Yeah, another circle. Okay, now this is only the upper part. Now we have to draw the lower part. So same from the yeah, you have to remove the inside of the cylinder. Actually, for getting a clear picture, you have to draw remove, because from this view, this side of view, that is from the view of the when we see the object, you can't see inside what happens, or the that corner of the square plate we cannot see. Okay, like now just draw two lines. Okay, in the bottom actually, in the corresponding from the cylinder, two lines, and it's exactly the circle actually, and remove the part. Okay, remove the inside part actually. Okay, only the outside part. So this will be that picture actually. Okay, the isometric view of the picture. Now another question. So here it is a little bit tougher one. This question is a little bit tougher one. So you have to clearly understand this question in a proper manner, because once it is asked for the university. Okay. So a hemisphere is centrally placed on the top of a frustum of a cone. Draw the isometric projections of the assembly actually. Okay. So this question is very important. Okay. Yeah. So as you know, the what is a frustum? Frustum is something like a part which is maybe a a pyramid like shape, and the top portion is cut out actually. Okay, the bottom portion, the remaining portion is actually the frustum actually. Now, yeah. So you can see here isometric. First, we have to draw the isometric scale actually. So isometric scale. Here I got, yeah, I got it, the isometric scale in the bottom. You can see that this is a 30 and 45 degree axis, and the radius actually. So the radius of this that cylinder actually, inside the cylinder, the radius is I just draw in the small r actually. Okay, and the small r is isometric scale. So small r. So capital R becomes the small r actually. Okay, what's the radius actually? So that is applicable to throughout actually. Okay, right. Now first you draw the line, axis line, and the second you have to draw the square plate. Okay, yeah, first square plate you have to draw, and then the height actually you draw the height. Actually the height is actually the 50 mm. So in the isometric, what will be the height? You have to draw it, and then you just complete the square. Okay, you don't need actually, but you have to mark the center point actually. From the center point you have to mark from the another point which is in the top view. You can see that there is a 30d. Okay, so 30 diameter is given in the top of the frustum actually. Okay, so that frustum top we have to mark the 4 points on the in the axis line. 4 points you have to mark and circle. Okay, so a square is drawn for drawing the circle, and then each and a part, okay, each side is I am going to draw. Okay, yeah, I'm going to draw and darkening it. Okay, so the circle is going to draw it. Yeah, already draw the circle, and now the bottom is also, yeah, the circle. I draw the circle, and now the sides. Okay, you can see here, you can see that there is a in the front view you can see that there is a 50d and 30d in the upside and the lower side. Okay, 50d is in the lower side and 30d is the upper side. So from this we understand that this figure, only the front view is given. From this figure we understand that this is a diameter, so that is a circular, actually circular shape in the bottom and circular shape in the upper one. Okay, for that drawing we draw the two squares actually. Okay, the bigger square in the bottom and the smaller square in the top portion. Okay, now so for actually you don't need to drawing exactly, you just need to draw the lower square and also the height and then upper square only. Okay, that is enough for you, but for getting more, that is why I just construct all these lines. Okay, now, yeah, now we have to mark we have to draw this hemisphere actually. That is a very tough part in here. So P and small height, that height how much actually? Here you are given the 50 diameter for the hemisphere actually. So diameter is 50, it means that the radius or the yeah, that height will be the 50 actually. Okay, so it's total diameter means the from the bottom to top height actually. So it is 25. Actually the 25 is the mm, 25 mm is the there actually, but 25 you have to draw it as an isometric scale. Okay, you have to take in the isometric scale and mark it. Okay, now the small r is given actually. Okay, so the capital R is represented as the 50d, and you have to draw it in a small r corresponding isometric scale value. So yeah, from that you have to, yeah, capital R. From the capital R you have to draw a circle. Okay, so from the topmost point of small r, just at the center point, as a center point, draw an arc actually. Okay, once more I'll show you. So you draw a height and point is a small point, and then the radius of capital R, just to draw a circle or a sphere actually. Okay, a sphere. Now what you are going to do is you just half it, yes, and a small r, and this small r distance you just draw an axis, a square. Okay, yeah, square you make it, and another circle. Okay, that is an elliptical shape. Once more I will show you. After drawing this circle, you just half it and draw the small distance. Actually, this axis distance smaller in both side, and then another axis in the horizontal, yeah, and top and bottom, that smaller distance, and another lines, two construction lines, and then yes, an elliptical shape. Then remove all unnecessary parts actually here actually. So you will get this shape actually for this hemispherical centrally placed over the top of a frustum actually of the cone. Okay, so I think now you understand this is small, I mean a little bit tough part actually. Okay, this problem is a little bit tough, so that is why I told you. So very concentration is each and every problems are different types actually in here isometric. So isometric problems are it depends upon when you your imagination is clear actually. You have to imagine every problems, okay, how you are going to draw. So and also the practice is also important. Now the next and another problem, it is front view and top view is given actually a shape which is having a front view and top view of an object, and you can see that there is a cylindrical portion in the there actually, and a height and a slant is there, and a plate is there actually, which is having a height of 10 mm, and the cylinder portion is having a height of 40 mm, and the width of this plate is 50 mm, okay, and the total length of this plate is 80 mm, okay. Now you just clearly understand about these all the dimensions actually, okay. If any dimensions is not given, find out that dimension from the other dimensions, okay. So see here, it is not given the distance of the centrally portion, okay. So the central portion, you can see that there are two edges, okay. I will draw it. So first we want to draw is a line, okay, then similar manner, okay, mark it as an O, and you just draw the another line, yeah. So this is the plate actually I'm going to draw, yeah, the plate is completed now, okay. So one of the corner I picked up, that is a point O, you can see then here that corner I picked up and I draw it, okay. So now the plate is ready actually. The height of the plate is 10 mm, and the length is actually one side of the length is 80 mm, and another side is 50 mm, width is 50 mm. And now I'm going to draw a square actually centrally placed. As you know that when you there is a cylindrical or a circular shape, you have to draw a square actually in the first. So the square I placed and a cylinder I placed, yeah, top and bottom, and joining it. Now the cylindrical portion is there. Now I just place these side lines actually, the slanted lines, okay, and draw it from here and then there. Remove the unnecessary parts, okay, and the drawing is completed actually, okay. So this is actually happens in the yeah, so all the dimensions you should aware about this, okay. So that is the height of the cylinder is the 40 mm, and this height of the plate is 10 mm, and the diameter of this plate is 30 mm. So all these dimensions you should aware very well actually, okay. So when you got a front view and top view, you have to imagine what should be the shape of that when it is placed in an isometric view, okay. Then only you have to start the drawing actually. So before that you have to draw, that is an isometric scale conversion actually, okay, right. Now anyway, thank you, and please subscribe my channel, okay.